This video is supported by the National Science Foundation. Hello, fellow researchers and AI enthusiasts. I'm Dr. Ronald Wilson, a research assistant professor with the Florida Institute for National Security, and welcome to a short course designed by my team on AI-enabled assurance of semiconductors using image analysis and machine learning. I know it's a mouthful, and you probably haven't come across a similar course or terms in any open courseware, but you'll learn about them in the following lectures. This unique course is designed to give you an insider's view into a very important area for national security called hardware security and assurance. Oops, oh, yeah, I'm just kidding. If you're wondering why I have a movie poster in the slides for a very serious AI course, that's because it's very relevant. Other than implying a good paycheck and learning industry relevant skill sets from this course, this movie introduces the concept of reverse engineering in a fun and interesting way. The movie introduces Ben Affleck, who reverse engineers a TV from Company A, isolates their secret sauce, and uses the knowledge to build a better TV for Company B, earning a huge paycheck. In the real world, we call it intellectual property theft. Now, the idea for breaking down a product into its basic components gives us an opportunity to modify and insert elements into the product that did not belong there. These are called hardware trojans. Now, think about all the hacking cutscenes that you have seen in movies, like listening in on conversations, intercepting messages, turning off critical devices. All of these will be a possibility with hardware trojans. Now, you'd be wondering, how can one easily place a hardware trojan in a device? It's not software, it cannot be installed remotely. Then how does this happen? So for semiconductors, their life cycle begins with the design process. Since the design process mostly involves software, it's easy to design and develop, even from home if you have the required skill set. But manufacturing them is a tad bit more complicated. It's not like we can 3D print them at home, right? So we send the design to a foundry for manufacturing. To save on cost, these are sent to foundries abroad that can manufacture at scale. And since these are foreign entities, it's hard to ensure a secure environment. And naturally, they can't be trusted. This is where the hardware assurance process comes in. Hardware assurance verifies and validates the design through reverse engineering to ensure that the manufactured devices are trustworthy. Now, how easy is it to verify? I would say it's very easy, but let's just do an activity. Can you spot the difference between these two images? I'll give you 5 seconds. Now, if you found this, you're pretty good at finding Waldo. Now, let's zoom out a bit. How about now? How about now? How about now? This is literally finding a needle in a haystack. And this is still a very small region on a single layer in the integrated circuit. Essentially, is something we call a toy problem. Developing reverse engineering for hardware assurance also has significant financial impact. Unlike consumer products that change annually, a majority of the large-scale engineering projects span decades. They will also remain in service for decades, like the F-35 program or the satellites. Now, procuring replacement parts after decades of service will be a very hard proposition for many of these national security applications. And these prompt either re-engineering the product or developing a new product altogether. So reverse engineering helps resolve this issue by generating replacement parts even after decades. Even if the original product is no longer available, the company no longer exists, as long as we have one working copy. So if you're wondering how we know about all this, no, it's not from Wikipedia, it's our team. We are the Florida Institute for National Security, also called FINS. Our team has Dr. Woodard, the director of the institute itself, with decades of experience in applied AI research, including computer vision and biometrics. The assistant director, Dr. Forte, Dominic Forte, has decades of experience in hardware security and assurance, and me, who wrote my dissertation on identifying open problems in reverse engineering and developing algorithms to resolve some of these open problems, making reverse engineering and hardware assurance more accessible, efficient, and accurate for industrial use. And our team of researchers and students, experts in reinforcement learning, generative AI, and explainability. Hardware security and assurance is only a single area of focus for FINS. Our research is spread through all areas of national security, with emphasis on applied AI, and we hope to impart a part of this expertise to you through this course, getting you ready for the necessities of tomorrow. Now, going forward, we will discuss in detail about semiconductors, imaging methods, image analysis techniques, machine learning and deep learning methods, and applications of AI for reverse engineering and assurance. Hope to see you guys in the next lectures.